All right, we're back. We're on page 193 now. If you've been watching these consecutively, it's still the same day as the hurricane-like conditions. It seems to have passed. I'm not anticipating losing power. I don't know. Hopefully this all works out. But I'm feeling pretty good. Better, at least. Had one tree hit the house, one tree hit a shed. I don't know. Not a great day. But let's see if we can do this. So it's really helpful to play around, look at a bunch of things. So I recommend that you do this. Like take out a calculator or punch them into GeoGebra, make a point move around them, see what happens. You can use trace on your calculator. You can actually put a point on it and watch it animate in GeoGebra, whatever. It'll give you a sense of these sorts of things. We're not gonna do it in the video because that's not why you paid the price of admission, which was nothing. So let's see instead if we can do this problem. So write parametric equations for a particle moving in a circle centered at 2,5, has a radius of 4, takes 500 minutes to complete one revolution. So notice it doesn't tell us which way to go. If it doesn't tell us which way to go, that's secret code for counterclockwise. And it doesn't tell us where to start. That's secret code for start at the rightmost point. Why am I choosing those things? Because of the unit circle. So basically we're just messing around with the unit circle here. We're gonna shift it. We're gonna increase the radius. We're going to change the period. So we're going to start with changing the period, actually. So the period is supposed to be 500, and that's going to be 2 pi over b. So then b is going to be pi over 250, which is kind of crazy. Okay, x is, y is. So we got to start at 2, 5. So 2 and 5. We weren't told what direction to go, so we're going counterclockwise, which means they'll both be plus. The radius is 4. And then I'm going to go with cosine of really the only place, well, you could go wrong a lot of places, but the most likely place is to forget to change the period. And then sine of pi over 250 t. And there we go. Okay. So that's it. That'll do it. Let's try this next problem. So it's a little different, possibly more interesting. So a particle moves around a circle with center 3, 8, beginning its motion at -610. This is different. So instead of having a circle and starting like here or here or here or here, like north, south, east, west, instead of that, we have a circle and we're going to start like, I actually don't know where, like maybe here or some like odd point. Odd is in like not one of the cardinal directions, not north, south, east, west. So what are we going to do? Well, we're going counterclockwise. So what I'm going to do, and honestly, now I'm thinking about it, I don't know how long this video is going to be. Hopefully not forever. What I'm going to do, oh, I feel like the lights flickered, or I blinked, and now I can't trust anything. Like, I don't know. I need the radius, right? So let's just start with that. Let's use a pen. The radius is the square root of -6 minus 8. So 9 squared plus 2 squared. So what are you? Radical 85, I guess? Okay, well, why would you write 1? Radical 85. All right, so I think that's the radius. That's fine. We're just going to use that. Now, let's just write equations. So what we're going to start with is we're going to start with like a base case. So I'm going to say that this is like my base equation. I'm going to do it in blue. Base equation. So I'm going to write a set of parametric equations that do basically what we need, but don't take the start into consideration. So like, I don't really care about the start right now. So I'm interested in a little bit of a sketch. Well, actually, I don't even need a sketch. So I'm just gonna go counterclockwise and have that radius and that center. So, I mean, it's, there's a lot going on. So counterclockwise is just the unit circle. Cosine of t. And then plus radical 85 sine of t. All right, now that's my base equation. What I'm going to do is I'm going to modify that to create the actual scenario that I need. So I need to start at -610. The question I want to answer is, for the base equations, when do I get to -610? Like, what value of theta or t or time will put me at -610? If I can answer that, then I think I can answer this problem. So let's see if we can answer that. And the way I'm going to do that to begin with is I'm going to create a graph. And the graph that I create is gonna, so I'm using these gray axes. So usually when I use the gray axes, what I'm doing is they're not the real coordinate axes. It's not like the x-axis, y-axis. It's just horizontal and vertical. And in the middle of the gray axes, I'm going to put the point 3, 8, because that's the center of the circle. So now, once I have that, it's pretty easy. Like negative 6, 10 is going to be like wherever. Like let's say here. I have no idea how this is going to work out. Like I feel like that's not a proper spacing, but I also feel like maybe I don't care. Maybe I should care. So like 10 is 2 above and negative 6 is like 9 over. So it's probably more like this. Okay, so this is going to be negative 6, 10. All right, so let's put in a radius. And let's actually draw the circle. Wow. Nope, that was so bad it couldn't even like autocorrect it. Oh, what? You can make an ellipse? I did not know that. So that's great, but not helpful. Circle, okay. And then bigger. And I don't know how I'm gonna do this. What the? Okay, apparently you could always make an ellipse and I just had no idea. All right, so what's going on with this circle? We wrote our base case so that it's basically the unit circle, which means that you're here at t equals 0, you're going to be here at t equals pi over 2, you're going to get here at t equals pi. The question we need to answer is when do we get here? Like what time, what value of t or theta or whatever you want to call it are we getting here? So I really just need to know what is this angle? And I can work that out. The reason I can definitely work that out is I can use this triangle. So if I go down here, why would you even think that that was supposed to be that? You know what I'm talking about, right? Like here, there to there. Okay, so this is a right triangle, and I can use that to find the reference angle. And so what are the dimensions of this triangle? Well, I actually kind of said them while I was doing this, I think. This distance right here is 9, because this is 3, and this is negative 6. So that's 9. And then this distance is going to be 2, because this is actually 8, and this is 10, and the distance between those is 2. So the reference angle here, so let's call this, I'm going to call it alpha. So alpha is, let's say, inverse tangent of 2/9. So then the actual angle, though, that we're going to use, this is theta, is pi minus alpha. So pi minus the tan inverse of 2/9. Okay, what does that mean? That means if we start the timer at 0, and let it count up. It'll be at 0, you're here. Counting, counting, counting. At pi over 2, you're here. Counting, 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 counting. At pi minus arctan of 2/9, you are here, and then you keep going. So here's how we can modify our equations to make this actually work. So over here, I'm going to say equation start at negative 6, 10. So we needed to do all that work. We're going to take our base equation and modify it just a tiny bit. 3 plus radical 85 cosine of something. And then y is 8 plus radical 85 sine of something. All right, so if I want to start at this point, then what I need to do is I need to make sure that when I plug in 0 for t, I get this angle. The way I'm going to do that is I'm just going to say that the angle that we're working with, the argument here is t plus the quantity pi minus tan inverse of 2/9. 1, 2, 1, 2, 3. And this will be the same. Pi minus the tan inverse of 2/9, close, 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 I think. All right, so now the question is, did it work? And if it did work, can we do the other problem? And I think that we could now make it start anywhere. I think we could. I think that as long as we can kind of like focus on how it works, we'll be able to do this. So I'm going to do two things. First, I don't know if this gets bigger in the videos when I do this, but I'm going to do it anyway. I'm going to click on, oh no, law. Okay, click on this just so it like opens up. That should be your first step. Your other first step maybe should be to, well, whatever. I was gonna say like to turn off the labeling everything. I'm just gonna do a circle. Circle 3, 8. Can I just give it another point? Negative 6, 8. Can I do that? Oh, well, negative 6, 10. Yeah, I can. Look at that. It even found the radius. Learn something every day. Zoom out. All right. So let's do our base equations, right? So that's going to be curve 3 plus square root of 85. I should just store the square root of 85 so that I can use it, but I'm not going to. Cosine of t, nope, 8 plus the square root of 85 sine of t. And then t goes from 0 to 2 pi because there was no time stipulated, and therefore we just assume. Here, and then if I do a of like v, we'll make a slider for v, and we'll let v go from 0 to 2 pi plus point, but you know what, just do 6.38, 6.3, whatever, bigger than 2 pi. Okay, so at 0, we're there, and so this is doing what we expected it to. Now, what if I do a of our offset, right? We think we get to the point negative 610 at pi minus arctan of 2/9. Look at that, pi minus arctan of 2/9, when we plug it into our base equation, does put us at negative 610. So let's try to modify our equation and see if it worked. So we go here, I'm gonna duplicate, I'm gonna go down here and do plus, you don't need parentheses around it, so I'm not gonna put them because it just, like, it's so much stuff. Arctan of 2/9. Ooh, messy. It'll fix itself a little bit when we start typing here. So plus pi minus arctan of 2/9. Okay, so now we only see one thing, so possibly this is good. So I'm gonna hide point A because that's just using the base equations. So B right now is negative 610. That should be where we start when I punch in the next thing. So let's see. I want to do B of V, right? So B of V, let's see. So B of V, so when V is 0, we're at negative 610. You can see it down here. Potentially that's in the video, I think so. I'm gonna hit play, and it's going. So this worked. All we had to do, not all, I mean, it's a lot, figure out the offset. Right? So if we, for example, let me go back. I think I'm just going to do this problem in this video. I'll come back in the next video and do like the next part of this problem and basically run through it again, like from the start, which I think is probably almost necessary. Another like good point that we could start at. So good points are hard to come by on circles. You get like your cardinal directions potentially, but not even necessarily. Like here, 3 plus radical 85, not that great. But by symmetry, if negative 610 works, then negative 6, 6, I think should also work. Negative 6, 6, right, would be down here. So let's say that I had wanted to start at negative 6, 6. So if this, what colors have I not used? This like dark green. Say I wanted to start here. All right, well, I would need another kind of reference angle, and I'll call it beta. But beta is actually still arctan of 2/9. But this time, the full angle is pi plus, right? Because we're starting here and going to pi and then plus beta. So I think that if I go back to GeoGebra, and this, I don't know, I'm going to say this should be quick, but it'll probably take forever. I'm just going to duplicate this one. This actually should be quick. Duplicate this, click in here, and change that minus to a plus. I think now, because I'm offsetting by pi plus arctan of 2/9, I think that at t equals 0, we should be at -6, 6. So let's put a point on this. So this is, the curve is d, so d of v. So when v is 0, when I have 0 is the thing I'm plugging in, I think I'm at -6, 6. And I am. And if I animate this, I think they're all going to go counterclockwise. Very nice. Okay, so this is working. So I'm going to stop this, and I'll go back. So think about it and see if you can do it. There should be 2 more good points kind of on the other side of the circle that you could definitely work with. Or just try to make it start straight up. Start at the left, start at the right, just by offsetting the angle instead of like changing our trig functions up. So I think the other good points, what is this? This is 9 this way and 2 this way. So if you go 9 this way to 12 and 2 this way, so 12, 10 I think should be good. And if you go 9 this way and 2 this way, so 12, 6. I think trying to start at those, perfectly good idea. I'm gonna come back in the next video and do this, where the big difference is we're gonna go clockwise. And to go clockwise, so try it on your own. To go clockwise, I will give you the hint. The hint is change up your base equations. Also, we could have done this again with different base equations that put us at different places at t equals 0, pi over 2, pi, and so on. And then our offset would have changed. I don't think that's a great idea, but we could have done it. So I'll be back in the next video where we are going to like change things up. So I'll see you there.